purpose of this video is to show you how you can use ChromaChecker to build G7 plate curves and eliminate doing dedicated press runs for your G7 plate curves. So it's essentially using a G7 calibrated color bar to iterate your plate curves from normal color bar information that your press operators are already measuring. As long as your press operators are using an open architecture type measurement device like a X-Rate IntelliTrax, this capability is for you and can save you thousands of dollars. So we've engineered a G7 calibrated color bar that still has solids in every ink zone, but gray finders in between, as well as tints, so that a press operator can see how the press is performing, and the plate curve person can use that exact same data to iterate a plate curve. And that's what we're going to do today. So in my ChromaChecker print inspector dashboard, I see my Epson, my Canon, my Indigo all have green checks telling us they are G7 compliant, so they have a shared visual appearance. The low E factor tells me they're close to the given grackle condition that I'm aiming for. Now if I move to my Heidelberg, I see a red X and I see a 6.8 E factor. So 6.8 shows me there's a fair amount of difference between how my press is printing and how it should be printing to match grackle, or match my proof for that matter. And the red X tells me it's not G7 compliant. So let's fix that. So I'm going to go into the magnifying glass, and what we're looking at here are over 84 different measurements of the color bar. And the overall E factor, or the accuracy E factor, is showing me how close the press is printing to grackle. So this is really an indication of how good the plate curve is to match grackle. Now the blue line here represents the within sheet variation. So if you can imagine, each color bar has multiple patches that have identical values, and what ChromaChecker is doing is it automatically compares those identical values and says what is the delta E of each of these values, and it's calculating the 95th percentile of all the values are up around a 4 E factor. That's a 95th percentile, meaning if we did a peak delta E, the number would be even higher. And one of the things I've learned by looking at this many times is most companies want to run their press in about a 4 E factor. Well, if the press isn't 4 to itself, there's no way with the plate curve we're going to make it a 4. So the first thing we can tell ourselves is either the mechanics of the press are not capable of consistently hitting a 4, or the operator's mastery of the press is not capable of being less than a 4. So first thing is that operator, if we want to be in that 4 range versus a 6 to 7 range, we need to get control of the press to itself. Now, that being said, our accuracy, if the curve is working well, is about 50% more than our within group variation. So the fact that my press within sheet is around a 4 E factor and the press accuracy is around 6 to 7, I'm making a judgment that this plate curve is actually doing pretty well. But no matter, we're going to show how we can use ChromaChecker to make it even better. So first thing I want to show is this is our summary screen showing you the precision and the accuracy, which is really great from a troubleshooting perspective, because as you saw right away, I can determine is the problem in the operation of the device, or is it in the application of the curve? And from what I'm seeing, it's in the operation of the device. And if I go to my primaries here, so instead of looking at a summary of all the patches, I'm just looking at my solids. You can see the solids are hovering around a 3 to 4 E factor, which is pretty high. I mean, ideally, we want to be living down in that sub 2 range if we have any chance of getting to an overall 4 E factor of our press. So right here, I know, boy, I've got to spend some time with the operators, and ideally they should take our training course, which is built into ChromaChecker, on how to get their solids right, how to get them even across the page, and how to monitor their dot gain to make sure it's consistent, because that's critical for G7 curve as well. Now, You'll see down here, here's my 84 plus measurements across about 8 different jobs. And you can see the operator chose production on some of these sheets and make ready on some sheets. So the operator was saying what he thought was sellable and what wasn't. And you can see how well he did with the solids on some make readies. And to build our curve, what we're going to do is we're going to eliminate any of the make ready. So when I say refresh, now these are just the sheets that the press operator said were production worthy, so sellable. And you can see the volatility went down a little bit. We don't have as many 5s and 6s in here, but our average is still around a 3. So it's a good start. So now I'm going to take all of this data by clicking on select opposite and bring it into my G7 curve inspector. And what ChromaChecker does is automatically throws out any measurements, any color bars where the solids or overprints don't conform to the 3.5 delta E required for grackle targeted. And it leaves me with the ones that have the right densities left. Although here it's showing me the amount of variation in the dot gain of these measurements. So in order for the G7 curve to be right, the solids have to be right and the dot gain has to be right. And if there's too much variation in the dot gain, then you can't expect the curve to be right. Most press operators learn how to at least hit the solids, but many don't learn how to control and monitor their dot gain. We have a specific course in ChromaChecker sheet fed operations, press operations, to help a press operator to understand the variables that affect dot gain and how they can look at it. Now, I'm isolating one measurement here. It looked like it, even though the solids were right, it was pretty far off. So I'm going to deselect it from my list. And it makes my grouping a bit tighter. Although, again, in my opinion, a little too much variation here in the dot gains. But that's okay. We already know that. So I'm going to say use these files. So ChromaChecker groups them into one whole file. And if I go to my measurements, you'll see here's the average dot gain for my cyan and my magenta and all the other values around it. And if I hover over one, I can see what sheet number that is if I want to. And I can even go deeper to my group variation and it'll show me the distribution of all of these patches. So if you look at the black, there's 167,000 combinations of black being compared in delta E. The single worst comparison in this grouping of all these measurements that I just grabbed is 11 delta E, and the 95th percentile, or what we call E factor, is a 5.35, which, again, a lot of variation. The 100% CMY, 12,000 combinations, almost 21 is the peak, and almost 12 is the 95th percentile. So all the things I talked about in terms of the press not being very precise is showing up in these numbers in spades. Look at the variation of the 50, 40, 40. 21,000 combinations of patches. So this is a phenomenal amount of data we're comparing. And we can see that the peak is 6.44. The E factor, 95th percentile, is almost 4 delta E. Again, that's a lot of variation for that 50, 40, 40 patch. We're going to say, okay, we understand this. We're going to go ahead and build a G7 curve anyway. And when I go to my G7 curve, it's telling me how well my existing curve is doing. And this being a ChromaChecker user using ChromaChecker, you can see it's actually doing quite good. For G7 compliance, we need the 4 NPDC values to pass. 2 of them fail, 2 pass. And the 2 that fail, it's not that unreasonable. It's not that far off. And then in the gray balance, the 2 are passing fine. So the gray balance is actually looking pretty good here. So this just reiterates what I said earlier, that I don't know that by building a new plate curve on this press and putting it into the workflow is going to help much, because the variation of the press itself is the problem here. It's what we need to fix if we want to get our press more accurate to the proof. But no matter, we're going to keep going, and I'm going to say calculate with this data my new plate curve. And up ChromaChecker comes, and it gives me the data related to the new plate curve. If I had an existing plate curve that I was working from, I'd load it here. My export to file allows me to export to my given workflow, so this new curve can be downloaded into my workflow and applied correctly. You can see that it's kind of a push for all the colors to increase the tonality. Here are the specific values. And you can see it needs to be a push because this black line is where my press is. It needs to be where the green line is, so it does need a push in terms of the color. And if I run my press at perfect densities and perfect dot gains, based on the average of those sheets I just took, my virtual press run will show that I will be dead on Grackle with a really good match. And then the question is, well, what were those densities and dot gains of the average data? And it's shown here in the printing guide. So here are the absolute densities for my cyan, magenta, yellow, and black. So the press operator should hit these densities, have them even across the sheet. And more importantly, here are the dot gains they should be hitting after this plate curve is applied to the press workflow. The plate curve was where the black line is. The plate curve should be where that red line is. So we're doing a virtual press simulation of what that dot gain should be. And a press guy does not have a G7 button on the press. He only has density and dot gain. We're telling him what the densities should be and what the dot gains should be. If he hits these exact densities and these dot gains, he will hit G7 every day of the week. And our training course for sheet-fed press operators has a whole section for the operator on how to control the dot gain and what variables impact dot gain. So please take your operator through this because it will make them much more capable in terms of hitting the press in its right condition. And ChromaChecker, once the curve is built, keeps a history of the curve. So you can go back at any point and see how the press was running when the curve was built and go in and get added detail about that curve, whether it was built a year ago or a month ago. So the G7 Curve Inspector built in ChromaChecker allows you to eliminate dedicated press runs and keep your press printing in a G7 condition, which gives you a shared visual appearance across all your printing processes. Hope you enjoyed this.